Hello and welcome to this Python tutorial. So we just trained our artificial neural network on the training set, and now time to make the predictions on the test set. So the good thing is that we have everything ready here. We actually don't need to change anything to make the predictions because even if we made this classifier object with Keras and not scikit-learn, well, there is the same predict method to make the predictions on the test set. So we can directly select this line and execute to get the predicted probabilities. Great, so let's have a look. ypred is here. Let's double click on it. Here we go. And that's all the probabilities that the 2000 customers of the test set leave the bank. So for example, if we have a look at the first probability, 20%, well, that means that this first customer of the test set indexed by 0 here has 20% chance to leave the bank. So making these predictions on the test set will be interesting for us to evaluate the performance of the model on new observations, because the accuracy we obtained in the previous tutorial was the accuracy on the training set, but right now we're making some predictions on new observations, and so it's very interesting to see if this accuracy is going to be as good as the one obtained on the training set. And we'll get this accuracy on new observations thanks to the confusion matrix that we'll look at afterwards. And then, if we get a good accuracy on the test set that is, close to 86%, the one that we obtained on the training set, well, that would validate the model. And so next, what's very interesting to do for the bank is to use this model that we just validated thanks to the test set on the customers of the bank. The bank will then be able to apply the model on all the customers of the bank, and by ranking the probabilities from the highest to the lowest, it gets a ranking of the customers most likely to leave the bank. So then, for example, the bank can have a look at the 10% highest probabilities of their customers to leave the bank, and so make it a segment, and then analyze in more depth thanks to data mining techniques to understand why the customers of this segment are the most likely to leave the bank. And so overall, this artificial neural network that we made creates a lot of added value for the bank, because by targeting these customers most likely to leave the bank, then the bank itself can take some measures to prevent these customers from leaving. So now, let's hope our model is validated on the test set, and so that's what we'll see right now, thanks to the confusion matrix. Alright, so I'm going to press OK here, and so let's have a look at the results of the confusion matrix. However, before we do this, we must be careful with something. This predict method here returns the probabilities that the customers leave the bank, and in order to use this confusion matrix, we don't need the probabilities, but we need the predicted result in the form true or false. So we just need to do a little something here to convert these probabilities into the predicted results in the form true or false. And to do this, we need to choose a threshold to decide when the predicted result is 1 and when the predicted result is 0. So we predict 1 over the threshold and we predict 0 below the threshold. And of course, a natural threshold to take is 0.5, 50%. In medicine, we can take higher threshold if what we have to predict is sensitive information, like for example, if we have to predict if a tumor is malignant, but here we're just predicting if a customer is leaving or staying in the bank, so 50% threshold is fine, and that's the threshold we'll choose here. Alright, so the trick that we're going to use now is, to update our vector ypred of predicted probabilities, so equals, and then, so this trick is to add some parentheses here, and inside the parentheses we input ypred larger than 0.5. And that syntax here is equivalent as if ypred is larger than 0.5, then it returns true, and if ypred is not larger than 0.5, then it will return false. So let's check it out. I'm going to select this line and execute. Alright, so now ypred is updated, and if we have a look at ypred now, we see that we get the result in the form false or true. So the first customers of the test set don't leave the bank according to the model, and the customer number 6 in the test set leaves the bank according to the model. Great, and so now, thanks to this form, we can execute this code to get the confusion matrix. So let's have a look. I'm going to select these two lines here and execute. Here we go, executed properly. And so now let's have a look at the results to see the number of correct predictions and the number of incorrect predictions, and then eventually the accuracy on new observations. So let's see. So out of 2000 new observations, we get 1550 plus 175 correct predictions and 230 plus 45 incorrect predictions. So that looks really good. We will confirm that right now thanks to the accuracy. So let's press OK here and let's compute the accuracy. We'll compute it here in the console. So the accuracy is the number of correct predictions divided by the total number of predictions. So let's see. We're going to put in parentheses first the number of correct predictions, which was 1550 plus 175 correct predictions, and then we divide this number by the total number of predictions in the test set, that is 2000, and what do we get? We get an accuracy of 86%. Awesome! On new observations, that is observations on which we didn't train our artificial neural network, well, we get an accuracy of 86%. And besides, we get this prediction without being an artist. By that, I mean that we didn't do any parameter tuning, so maybe we can still get an even better accuracy, but 86% is really good, since it is the same high accuracy that we obtained on the training set, but obtained here on the test set. So eventually, we can validate our model and now the bank can use it to make a ranking of their customers, ranked by their probability to leave the bank, from the customer that has the highest probability to leave the bank, down to the customer that has the lowest probability to leave the bank. So great, mission accomplished, and congratulations for having built your first artificial neural network. That's the end of this section. Next section will be about evaluating, improving, and tuning our artificial neural network. I'll just give you a little homework in the next tutorial that will teach you how to make a single prediction and the solution, and then we'll move on to the next section. So I look forward to seeing you there, and until then, enjoy deep learning!